Today we're going to put our Azure Function API on steroids and let GraphQL do the heavy lifting. Good morning, good afternoon, or good evening, whenever it is that I find you, and welcome along to the channel. And I'm going to get my beg, borrowing and stealing message out of the way first off. So if you like what you see here today, then please do like and subscribe. It does help me out. And straight off the bat, I'm going to dive in and give a thank you for the inspiration to this video to this guy, Abdul Chan Salam, or I've probably got his name completely wrong there, but never mind, so apologies for that. But this is the inspiration for this. So we're going to use the Hot Chocolate library, which is a .NET GraphQL library, to give us the GraphQL functionality, and this blends Azure Functions with the isolated process model and the Hot Chocolate library. So let's go ahead and dive into what this looks like. So first off, I'm going to come over to the API project that I've got, and I'm going to add in the project references to the Hot Chocolate library. And if you haven't been following along to this point, this is an ongoing API Jamstack project that we're using, and we've already embedded a SQLite database into this using the Entity Framework core. So we've already got all of that in place. So now we're going to add Hot Chocolate on top of that existing database that we've got available to us. So we're going to bring in Hot Chocolate version 12, and once we do that and save that in, that's going to prompt us to restore. So let's pull those in, and then we can get rid of that. Then what we need is a new class, which is where all the magic happens basically. So inside of our API project, we are going to create a new class called GraphQL Azure Functions Executor, or Executor, depending on how you would like to pronounce that. But this is basically the bridge between Azure Functions and the Hot Chocolate library. So this is where our Azure Function is going to call into to actually invoke the Hot Chocolate library. So let's just paste in this code. And this is pretty much the code that came from that GitHub repository that I just showed you. So inside here, we've got a single method called execute query async that takes in our HTTP request data, which is what our Azure Function will receive. And it's going to pass us back an HTTP response data, which is what our Azure Function is expecting to pass back. In between all of that, it's then going to parse the request body that's coming in, which is our GraphQL payload in our case, and parse that into a configuration that the Hot Chocolate library is happy with. So we're pulling in, as part of the constructor, various Hot Chocolate dependencies that all get added into the dependency injection pipeline, and that's basically it. We execute the request, it gives us back a result, and then we prepare that result into a JSON response down here. And that's pretty much what this class is doing. So given that we've got that now all in, as she said, what we can do is go and add another class into our API. So over in our API, create another class called GraphQL API. So we're just separating out our Azure Function basically from the rest of our API, so that we know that this is the GraphQL aspect of our API. So what's going on in here, we've got a brand new class called GraphQL API Functions, takes a logger factory, and also takes our executor that we just created. So we hang on to both of those in the constructor, and then we've got a single endpoint Azure function in here called GraphQL, which takes only a post, as is the GraphQL spec. Everything is a post in GraphQL. Takes the request data, and it's literally calling that execute query async, and it returns back whatever that execute async returns back to us. And that's it for our Azure function. It's as simple as that. There's nothing more to go into there. So we've got our Azure Function in place. We've got the bridge from the Azure Function across to Hot Chocolate in place. Then what we can go and do is we need to add in a class that represents the query object of our GraphQL, and we'll kind of explain this a little bit more, but just come with me for now. So we'll create a class called query. So in here, we've got a class called query, which is just a simple C# class, nothing clever. It takes in our configuration and it takes in our logger, although we don't actually need the configuration. That's just there for future proofing. And we've got one method on this class called getAPIVersion, and that's literally getting the version information out of our C# assembly. Nothing more clever than that. But essentially what happens is that this becomes the root query object of our GraphQL API, and this getAPIVersion becomes a GraphQL method or operation or query that we can actually call on this API. So you'll see what I mean in a minute, but let's just save this, go over to Program CS, and we need to add a few things in here. So inside here, first off, we definitely need to add our executor into that so that we can inject that into our Azure Functions. And then we need to go and add GraphQL itself. So underneath the database registration, which is this bit here, we'll go and add in the GraphQL server, which registers the Hot Chocolate library as the GraphQL server. And we go and add our query class as being our root query object type. So this is what Hot Chocolate uses as the root of the query object. And so let's go and give this a run up. So while that's running up, I'll just come over here, and from the same team that give us Hot Chocolate, they also give us Banana Cake Pop, which is a GraphQL client tool to enable you to craft and use and test and browse GraphQL APIs essentially. And they host this in the cloud at eat.bananacakepop.com. So you can freely go and use this against any GraphQL endpoint that you might have. So once we've got our API up and running, which as we can see here, we've got our GraphQL method here on this localhost 7071 API GraphQL. Let's come over here, create a document, and we can just paste in our GraphQL endpoint, and we can apply that, and then we can ask it to reload the schema, and we instantly get a problem. So that's not a good start. We're off to a flying stop, as is usually the case. So let's just go and have a quick look inside of the developer tools, and inside here we can see that we've got access to fetch from origin eat.bananacakepop has been blocked by cause policy. So cause is blocking us because we're trying to access an API from a different domain than the one that it's being hosted on. But we can get around this. So inside our local settings JSON, so back over to Visual Studio Code, let's get rid of that. And back over here, inside our local settings.json, we can add in this host cause and accept everything policy, which is okay because this local settings is only used locally on your local development machine. This isn't posted up to Azure, so we're not opening up anything into our API. There's no security problem here. This is just to allow us to debug locally. So we can save that, stop the API, restart the API with that cause setting in place. Okay, so that's up. So we can come over to here again, and it's already got the URL. I don't have to repost that in, so I can just do a reload schema, and it says we're fetching, and this time we're all good to go. So we can get rid of that, and if I come over to the schema reference, we can see that we've got a query object, which is the root of all GraphQL. And it's got one operation or thing that we can call on it called APIVersion, which was the method that we had inside it, and it's going to return us a not nullable string, which is what the bang or exclamation mark means on the end. So we can come over here and you'll see that Banana Cake Pop instantly starts adding value. It wants to try and help us, so I can control space inside the query, and it tells me all the options that are available in there straight away nicely. So I get a nice IDE experience when I'm trying to form my GraphQL query. So this is actual GraphQL here, it's not JSON, yeah, because there's no quotes around this and there's no name value pair. This is GraphQL, it is its own language, even though it looks very JSON like. don't confuse the two. So now if I run that, you can see instantly I get my call across in 42 milliseconds, I get a 200 back, and I've got my data coming back, which is the GraphQL convention, and I've got the response from me requesting API version. So it tells me the response for API version is a string of 4 zeros and dots, which is my API version that I'm returning in that method from the version number of the C# DLL of our function API. So we've got a full end-to-end GraphQL call now happening, albeit that it's not actually calling our database. So let's jump back over and get our database working with this GraphQL API. So inside our program CS, we've already got our database context already hooked up. So we've got our HRDB context, and that's hooked up to a context factory. But what we need for GraphQL, and specifically for the hot chocolate library, is to create an attribute. So we create an application DB context attribute class, and inside there we are going to leverage most of the hot chocolate library. So it's a very thin attribute, this one. We get the use DB context attribute from the hot chocolate library itself, and we're just basically telling it the type of context that we want it to use. So what is the database context that we want for this particular attribute when it's used in our code. So now we've got that attribute in place, we can come back over to our query object, and as well as having get API version, we can add in another method to go and get all the employees from the database. So we use our attribute that we just created to indicate that this method wants to take a scoped service of our database context, and it's as simple as that. We get that database context, we get our employees out of that, and we return that as an iQueryable of employee. So that will get us a complete collection of the employees inside the database. So let's run that up and then come back over to Banana Cake Pop and refresh our schema, because our schema's changed. And that's done. So now when we come over here, we can see we've got this new method called employees, which returns us an employee, and we can navigate into that and see all of the fields that are available on an employee. So this Banana Cake Pop is introspecting into our API for us to give us all of the information that's available. So given that we have that, I can get rid of API version, I can select employees, and with GraphQL you have to explicitly say what data it is that you actually want to come back. You can't just say employees.star, for instance, and get all the fields. So you have to explicitly go through and request which data you actually want. So I'm only requesting the employee data here. And although I said I can get rid of API version, I could equally request API version as well. So let's do that. And you'll see that this will go across and give us, as well as the API version, we get back an employees collection, and we get back the employee ID of each employee inside the database. So we get back the complete database, basically, of employee numbers. So that's interesting and certainly could be useful in the right circumstances. But what if we only want a subset of that data? So let's come back over here and use some more GraphQL hot chocolate wizardry. And what we can do is we can add in these extra attributes on our employees to say that we want our employees collection to support both filtering and sorting. And as well as that in there, you actually have to go into the program CS and add that functionality into the hot chocolate setup itself. So inside here, we can do that and save that and restart again over here. Okay, that's built and up and running again. So we can come back over here, refresh our schema again for a third time. And if we go and look at that schema again, we can see that on our employees, we've now got where and order as being available to us. So what does that actually mean in real terms? So let's come back over to our query and on our employees, it basically means that we can give it some extra arguments in here. So we can say stuff like order and give it a field name. So maybe ordering by surname, and then descending, and then give it the employee ID, and we'll also request last name this time. So let's go and run that up. And you can see that we're asking descending, so we're starting at Z and then working our way back up the alphabet as we go further down through all the surnames that are in our database. So we can sort our results using GraphQL. I've not added anything to the code other than those extra attributes, which is absolutely magic, really, when you think about it. You get so much functionality from this, and as well as sorting, let me go and get rid of that again. And as you saw there is a where clause as well. So much like you get with a SQL where clause, we can go in and we can say where employee ID, for instance, and then give it an operation. So we get all these operations of where it's equal to, greater than. So we can say equal to, and we can request employee 100. And then all we get back is employee 100 and his last name. So it's really powerful what you can do with GraphQL. If you've not played around with it, I'd fully advise you to go and have a play around with it, and I think you'll be converted that it can offer a lot over what a RESTful API can give you. And so just to add on to kind of where some of this power comes from. So at the moment, we've only got our employees object here, and within an employee object, we have a department ID. So if I run that, I can get back his department ID. But what we can also do with GraphQL is we can drill down further into the graph. So let me just stop this again. And what we'll do is we'll come over to our API and we'll add a new class called employee extender. And this is basically going to extend the employee object and provide extra operations, or resolvers as they're called. So we're going to extend the employee object, and it's still a normal C# class, so we can do all our usual stuff with dependency injection, but we're going to add in an extra resolver to get us the actual department. And again, we're going to use our database context. So we take our database context. We also take in this iResolver context, which helps us to understand where we are in the graph in terms of our query. So we can use that resolver context to get the parent object. So we get our parent employee, and then off of that we can get the ID that we want to actually use to query into the departments object to go and get the department and return the department as a whole. Yeah, so this is what this returns, is a complete department object, but based on the ID of its parent employee. So hopefully this will make sense in a minute what I mean. So let's run this up. One thing I've forgotten, getting ahead of myself, over in Program CS, we need to go and add in that employee extender into GraphQL or Hot Chocolate so that it knows about our extension object. So everything that we do, we have to register with the Hot Chocolate library, but it's quick and easy to do. So let's save that. Okay, so that is up. So let's jump over here, do our usual, refresh the schema. Schema refreshes, and then if I come in here and do a control space, you'll see that I've got this department here. So I can do department, and then in there I can request department name, manager ID, location, all of that. But for now, let's just request the department name and run that up. And so now, as well as department ID 90, I actually get a nice descriptive name of department 90, which is the executive. And I don't have to query for the actual ID because it's already returned inside the employee internally within GraphQL API anyway. So when I do that, I don't actually return that back to the client. I'm not requesting it, but everything still works. So you don't actually need to request the data. That all still works. So you can drill down. It is a hierarchy. It's a graph of data, basically, is what we're saying. And you can drill down and add more functionality. So you could have more resolvers inside a department that go and resolve against the manager ID, for instance, and bring back that employee. You could do that. I'm not going to, but you can do that if you want to as an exercise. So what's the whole point of this? What are we actually trying to do here? So we've got a list of employees basically inside of our database. What if we wanted to show a list of new employees that have joined our organization? Let's start with our where clause, and we can do something like where hire date, and where that is greater than or equal to, and I'll just give that a literal, so you'll have to forgive the dates. It shows how old this database schema and the database that's within it has been knocking around from Oracle. So 2008 are some of the latest records that were added into this database. So it's a testament to how long it's been around and how useful it still is. But anyway, so these are the kind of new starters. So we'll pick March 2008 as being when we're trying to find the new starters that started this month, is what where we're trying to get to with this. So lots of brackets in here. So let's have hire date again. So where hire date is greater than or equal to 2008 March, and hire date is less than or equal to 2008 0401. Okay, so that's our, let's just see if we can format that so that you can see what's going on. So that's our query, and what we want returned is all the data that we would want to show inside a UI. So first name, last name, email, department ID, and the hire date, maybe to show when they started, department and department name. So we'll request all of that information. So let's run this up and see what we get. So we do get some data back. So we get employee ID 128, started on the 8th of the 3rd. So that's definitely, and he was in shipping. We also get Andy Sundar, if that's the right pronunciation. And he started on the 24th of March and he's in sales. And that was our 2 new starters. So it's a working query. And just one last thing that we can do is, rather than have this called employees over here, what you can do with GraphQL is you can get it to rename the data that comes back. So you can do something like that. And then when we run that, rather than employees, we get a nice new starters named array. So it can help you to shape the data and name it accordingly. So that's a good thing. So now that we've got our query, let's go and add this into our UI. So let's leave our GraphQL API running, and let's quickly jump over into our Nuxt pages and create a new page in there called new employees. And let's paste in a template of what we actually want. So this is our HTML. So what is this doing? So this is, we are expecting an employees object to be inside the data for this particular view, and we're going to iterate over that collection and create some divs, and we're going to get out from that employee the first name, the last name, and we're also going to call across back to the API using the employee ID to get their profile picture. So this is all stuff that we've done in a previous video that you can check out. There'll be a link up the top to give you that. And it's basically going to render the employee card exactly the same as we have done in that previous video. So we get employee ID, email, and department ID. So let's go and add in some more of this view so that we can actually pull this back. So we've got our usual layout to pick our layout so that our page renders the same as everything else. We're saying that we're going to have an employees array as the data for this. Then we've got our fetch, which is going to call across to our GraphQL endpoint. This bit is to do with the GDPR cookie consent that we have to do if they haven't already consented to using our API, because our API uses cookies, etc., etc. All of this is all available in previous videos if you check back through the channel. So we've got our GraphQL endpoint, which was what we exposed. And we've got our GraphQL query here, which is the one that I've just created inside of Banana Cake Pop. And if I just jump back over to Banana Cake Pop, what you can do is look at the transport request body, and you can copy that straight out of here, so that the query actually has to be inside of a query JSON payload. So this extra query object here, and then the rest of what's in here is basically what's over here from query downwards is what's happening. So we need to copy the transport request body when we're coming to our client side so that we get a proper HTTP request across to GraphQL. So then we use Axios to create a post request on the GraphQL URL. We pass it that GraphQL query, and then we get the response data back, and we get our new starters object back out of that. And that's what we assign into our employees object. Any errors we catch and log an error and put up a toast to say that something went wrong. Fetch on the server is just a Nuxt thing to make sure that this script only runs on the client side, not on the server side. So that's all the JavaScript in place. And I think I'm going to need from the employee search some of this styling. So let me just go and copy some of this from here across to our new employees. So let's save that and let's run up our Nuxt site, new employees, and we get our website, and it's querying for new starters, and there's our response data. So it's querying literally for employees that started between those two dates and bringing back all of that data about them and their profile pictures. So we've actually got a mixture here of data coming from a GraphQL API to find the actual responses, but then we're using a RESTful API to bring back the actual profile picture inside the HTML. So our Azure Function API is now a mixture of GraphQL and REST, which is an interesting concoction. So we've created a GraphQL or RESTQL API, whatever you want to call it. I'll leave the naming up to someone who can come up with a better naming convention than I can. So, but it's an interesting idea to mix and match these things, and shows the value of that you can get from mixing and matching these things together. So let's just go and finally do one last thing, and let's get rid of this department 80 here, because that's not much use. So let's come over to our HTML over here, and rather than department ID, we can change that to as simple as employee department and department name that we were returning. So it's literally just a change to the HTML that we're teasing out of the JSON. And incidentally, while we're here, I mean, these are hard-coded dates, so an exercise as well should be that you obviously look at today's date to work out what the new starters are, but for us, because this data is so old, that's not going to work. But you can obviously, as this is just a string, you can inject in, today's date quite easily, but I'll leave that for you to look at. So with our department in place, we can see that instantly when we come over, it's now refreshed, and it's now pulling that straight from the JSON so that we get a nice department name rather than a department ID. So again, you can start to see the power that GraphQL gives you in terms of being able to traverse the graph down and just get the data that you actually want to show on the UI. So for a UI developer, someone who's front end only doing Vue or React or whatever, having a GraphQL API to query is really powerful for them, because it empowers them to really present the UI, and they're not restricted by what the API gives them back. They can query that API completely. So that's all we've got time for today. So that was GraphQL, REST, all done, all running. Thanks for watching. Do like and subscribe if you found this useful or interesting, and I'll see you in the next video.